Welcome to today's video on section 4.5, writing equations of parallel and perpendicular lines. And let's just do a little review of these symbols. If you have two parallel lines, the symbol is that. And if you have perpendicular lines, the symbol is an upside down T. So that's more going to pop up in geometry next year, but good to go over it now. All right, so what are parallel lines? Parallel lines are two lines that never cross. They never intersect. They're parallel. And it turns out that when you have two parallel lines, their slopes are equal. And that's why they never cross, because they rise and run the same, so they never cross. Now, if two lines are perpendicular, it means they cross. Not only cross, but they cross at a right angle. And it turns out that their slopes are opposite reciprocals of each other. And you guys might not know that word. Okay, so an example of parallel lines, two slopes being equal, let's say the slope is 2 and the slope is 2. Okay, that's easy. But what would they be if they're opposite reciprocals? If one of them was 2, you would have to make it opposite and flip it. So if it's positive 2, it would be negative. And if you flip 2, it's negative 1/2. So you change the sign and you flip the number. Those are opposite reciprocals. And that would mean perpendicular lines. All right, let's do it. So it says write the equation of the following lines. And here they give you a line and they want you to be parallel. And they want you to also pass through this point. So I think I'm going to use point slope for these when I write my lines, because you're given a point and a slope. I think that's going to be the easier method. And then let's remind ourselves the formula. Y minus y1 equals m times x minus x1. Okay, so number 1, here's our point. And then what's our slope? Oh, I just drew over it. You're gonna, if you want it to be parallel, oh gosh, I can't see that. Is that 1/3? I think this says 1/3. Hold on, let me look. Yeah, 1/3. So if you want to be parallel to that, you want to use the same slope. They have to be equal. So we're going to steal the 1/3 slope. This -1 does not affect the problem. Don't even look at that. You only need to steal the slope and a point. And then we're going to put it into point slope form. So y minus y1, so y plus 5, because minus minus is plus, equals m, which is 1/3, times x minus x1, but minus and minus becomes plus 3. And you get to leave your answer like that if you want. Done. You could also distribute and subtract the 5 over and get it in slope-intercept form, but I think this form is better for this problem. All right, number 2, same thing. We have a point and we're going to steal the slope. The slope is -1, so we're going to steal, has to be the same slope if you want a parallel line. Okay, again, don't look at the 5, not helpful for this problem. You just need the slope and a point. And then let's do point slope form. It's y minus y1, so y minus 11, equals slope -1 times x minus x1, minus a minus becomes a plus 2. And you can leave your answer like that. All right, now down below it says perpendicular. So I'm going to get a new color for the perpendicular. Now, what's the new slope going to be? If the slope is -2 and it says perpendicular, what's the opposite reciprocal of -2? So opposite would mean positive, and if you flip 2, you get 1/2. It's going to be 1/2. That's what we're going to use. And then here's our point. All right, and again, point slope form, it's going to be y minus y1, which is 3, equals our new slope, 1/2, because it's perpendicular, times x minus x1. So minus the minus 3 becomes a plus 3. And again, this 1 did not matter, and this 2 did not matter because we wanted the 1/2. All right, number 4, the point is 1, -3. What are we going to use for perpendicular here? If it was 1/4 to begin with, what is the opposite reciprocal of 1/4? So if it's positive 1/4, the opposite would be negative. And if you do the reciprocal flip, instead of 1/4, it'd be 4/1, or just -4. Does everybody see how that's the opposite reciprocal? All right, we're good to go. We have our new slope, we have our point, and we're going to use point slope form. So y minus a -3 is y plus 3. Slope is -4, and then x minus 1. And you can leave your answer like that. Okay, and lastly, we want you to say, are the lines parallel, perpendicular, or neither? So all we need to look at is the slope. So what is the slope of line A? Well, this is in y equals mx plus b form, so we know the slope is 5. Or 5/1, whatever you like better. Now line B we can't tell yet because we have to get y alone. So we need to draw the wall, minus x, we get 5y equals -x plus 2. And then we have to divide by 5, heart method. And we get y equals -1/5 x plus 2/5. Okay, so what's the slope? Y equals mx plus b. This is the slope, -1/5. So m equals -1/5. All right, last problem, line C. Again, we don't know what the slope is yet. We have to get y alone. So we're going to add 2x to start. We got to get y alone. And that becomes -10y equals 2x. And then to get y officially alone, we have to divide by -10, divide by -10. And if you reduce, you get y equals -2/10 reduces to 1/5 x. And y equals mx, so the slope is -1/5. Okay, so now the question, which lines are parallel? Let's do that first. Which lines are parallel? If they're parallel, they have the same slope. So I'm going to say line B and C. These two are parallel. So parallel would be B and C. Which lines are perpendicular? That means they have opposite reciprocal. So 5 and -1/5, those are opposite reciprocal. So A and B are perpendicular, but so are these, A and C, 5 and -1/5. So we have two sets of perpendicular, A and B and A and C. And then we've covered everything, so none of them are neither in this case. All right, that's all. Thanks for watching.